Alrighty, we're live for day 3 of Avnica 2025. Um, and as per usual this month, we are working back through the archives and solving year 2015 as warm-up. Um, Quick addendum, if you saw yesterday, I turned my invalid functions into regexes, so this is a pretty much effectively a one-liner now for my day 2 solution. In fact, I could clean this up just a little bit more. Let me see. So the regular expressions get compiled, and those should be separate values. So I'm going to call that invalid equals that regular expression, and invalid2 equals that one. And now we'll just do invalid.matches here. Okay, that should give the same answer. Oh no, it does not. Matches is a car sequence to Boolean. Oh, wait, we need to turn it into a string. Sure. Where should we do that? I guess. Well, we can't do like this toString, can we? No, of course not. We'll just put n here, or rather id, and we'll just do id.toString. Okay, and then we'll break that line here. Honestly, it's not that much of a performance improvement. I like the readability of the first one better. So I might remove that. Or, rather just not commit it to GitHub. But we tried it. At least we tried it. Okay, so day 7. Where's our worksheet? Here we go. We were having performance issues. And if you look at my Am I Being Stupid list, Shitty Memo is one of them. In a circuit like this, if it's not an infinite loop, if there's no cycles, which I'm hoping there's no cycles, because then that'd be a much harder problem to like evaluate step by step and check if the circuit is actually stable. So I assume there are no cycles, which means there are probably just lots of components that are used frequently. So we need to memorize this. So let's memorize that, and then we can do some cleanup afterwards, because I don't like having like this union type here, and then all the branching it causes in the control flow. So we'll use a mutable map, collection.mutable.map from wire or constant to the output type, which is an int, which I think I will change back to short after this part. Da, 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 da. And then, yeah, make a memo. So val memo equals map dot and oh wait, we're not importing a map at that time. That goes down here. Map dot empty. Here we go. Okay, And when we evaluate, so this whole thing can be calc, lazy val calc. This is my usual pattern. One of these days, I think sometime in the past I tried making a function that will turn some other function into a memoized version of itself. So if that's somewhere in my library, I should just use that. But for now, we are just doing memo.getterElseUpdate, our key A, and the value calc. I don't need these right now. Oh, you know what? I do want to verify that because that correctness still matters. What's going on here? No given instance of type. Well, we've got a circuit. Wire to gate. We do have a given right here from wire to gate. Is this clashing with that because of a erasure on the types? No, it's not even a given. I mean, we could fill it in manually. That should prove to us that at least works, right? Circuit or using the circuit. Found a map from wire to gate. Required Scala collection mutable map. Oh, I see what's going on here. So when we did that immutable map import, we, even though the import is down here, that's the definition there. So I'll just do it here, put it all in line. Okay, so that should evaluate. Cool. Um, let's test that everything evaluates how we expect. Here's a day 7 text, by the way. And for those who weren't here yesterday, we're simply given instructions for assembling like a circuit, and we have to evaluate the output on one of the wires. So no need to read this whole thing, but down here are some examples. So 72. And I think that's having trouble with F and G. So we'll take a look at the values we get there. 507, 492, that's fine. G, 114, nope. Okay, H. Hey, that's all right. Oh, okay. I guess I'm not worried. Um, oh, wait. These are my comments. These are not the evaluation. Did it actually evaluate? Okay, yeah, it's evaluated. Okay. H and I are actually having issues. Okay. So this is like X. No. H. So not X. We'll look at the binary for that just to be sure. Because these are unsigned 16-bit. We don't have an unsigned 16-bit. We have a signed 16-bit, but it's just short. I mean, I suppose technically you could use a character type that's 16 bits. Kind of hacky, but that would be unsigned. Before we get to choosing types there, let's just see what these values look like. So h is actually eval x, not x. Okay, so not 1, 2, 3. We can comment these out. Let's at least say that showing up as 124 and negative 457. And then we can comment these all out. We're getting negative 124. We should get 65412. So let's do 123.2 short and negate that. Should be the binary that we want, right? And what's the binary for like 65? 65412 dot two binary string. And can that even be a short? Dot two short. Hold on, this should have evaluated by now. Okay, there it is. I suppose I should also see what 123 to binary string looks like, right? So that ends up as negative 124. Oh, right, look, 65412 too short is negative 124. Great, so we just need to like remove the overflow somehow. Well, if we made it 2-character, let's say we were to take 123.2 character. Right, so this is negative 124 as a character to show up as something else. And then once you convert that to int, will it still be negative 124? Kinda hacky. Hmm. Oh, let's compare this with negative 124.2 binary string. Just in int. Okay, we're still ending up with negative 124. That's a little bit annoying. Am I gonna have to like mask to get these to the right values? I mean, the bits are still correct, right? The bits are what we'd want them to be, and we're only ever doing bitwise operations. So as long as the final output is not like an overflow, I suppose we could just correct it if it's negative, right? Yeah, we can do that. We can correct it if it's negative. Okay. Hmm. Um, fine, fine. So we'll comment this stuff out. You don't need to comment that out. we'll comment out the answer and change out to the actual problem. And now the memo, I'm hoping that solves our issue. Okay, 2 seconds. Cool. 9:56. Let's just try that. Cool. Um, let's take a look at part two. If it's going to be complicated, then we'll refactor first. Now take the signal you got on wire A, override wire B to that signal, and reset the wires, including wire A. Oh, what do you mean reset the other wires? What does it mean to reset a wire? Here, I'll show you the problem text. So, I know we override B to that signal. So we can do circuit updated. Hmm. Um, B, excuse me. Okay, so we're overriding B to basically ends one, or a constant of ends one. And I suppose memo needs to be cleared. Memo dot remove. We're gonna remove B. And when you say reset the wires, I think it just means set to the value they were previously, which they already are. So I'm just gonna run with that. So val ends to equals eval or A again. But now we're given circuit.updated or using circuit.updated. All right. We still got 9:56. I'm not sure what's meant by resetting a wire. Hmm. Okay. Let's just reread the rest of the problem. Reset. Hmm. So we have left shifting, we have right shifting. You know what? I'm not even sure if I'm using the right to the correct left and right shifts. I mean, I assume so because we got the correct answer for part one. Oh, right. So we would want an unsigned shift, right? So we'd want the triple. Yeah, because these are like unsigned integers. Triple is the unsigned version, right? Unsigned right shift is triple. Yeah. Well, I mean, we could fix that. I don't think that'll have any impact. I'm surprised that it didn't cause us to fail, to be honest. Oh, right, there's no need for an unsigned left shift. That looks like a spam bot. Okay. We can deal with the bot later. Okay. Right. Do we still get the same answer when we use the unsigned right shift? Cool. But yeah, I don't really understand what it's asking for part two. Reset the other wires, including A. Reset to 0. Each wire has an identifier that carries a 16-bit signal. Okay. A gate provides no signal until all of its inputs have a signal. I'm not simulating like the gates like propagating the signal, which is part of why I wouldn't be able to handle like circuits or loops in the circuit. I don't think that should be necessary. Other possible gates include OR and right shift. Okay. Like, I suppose right shift is just never really used. Hmm. And if you right shift on a positive number, like in this test, then it doesn't make a difference. Mm, what new signal is ultimately provided to wire A? Well, we are asking that question here. I suppose any constant gets reset to 0. Is that what we're asking? So we could do. We'll try that. Circuit.map. So val circuit 2 case we have our wire and then gate. And we'll say if gate is a constant. Um yeah. So we'll just do this. Constant of some whatever Then we go to wire, and then constant of 0. To map, and then any other case, of course. Case WG, any other case should become just that same case. Still pointing to a gate. To map, and then we'll do this updated for B. Dot updated B. And then now we can just do using circuit 2. Let's see if that's what's meant to happen. It should at least give a different answer. Not sure if it'll be the correct answer. Oh, there we are. Wait, it's the same. It's the same answer. Oh wait, we need to remove all the values in the memo. Let's see, memo.remove all. Oh, I suppose, yeah, I suppose we just have to make a new memo altogether. So how do we clear a mutable map.clear? There we go. Yeah, let's just clear it. That's why. Okay, so let's start with just the updated version, because I don't know what's really meant by reset. Circuit.updated. Okay, this time we've cleared the memo. That's the issue. We were still caching the previous answers. $41.49. That looks better. $41.49. All right. I'm curious what this is doing. Like maybe if we graphed this, we would be able to kind of reverse engineer what the circuit is actually doing. All right. These tests can continue to exist. And they should continue to exist because we're about to refactor things a little bit before we move on. In fact, we might not move on to day 8 because we've only got 20 minutes left. Timer 18 minutes. Okay. Day 7. Oh, we're going to go with the example for now. Actually, this evaluates fast enough. Okay, so there's a little bit of messiness here, right? When we're evaluating a wire or a constant. We're treating those kind of the same. This here is sort of the same thing as a wire. It's like a ref to another wire, and then constant is like a gate. So I think these two kind of stand separate from gates and shouldn't be in the same hierarchy. Um, yeah, in fact, maybe we'll just have a type for a wire. So We have a constant reference and we have a wire reference. Let's use that. So enum ref, a constant reference is an int, and a wire reference has a label. And we'll just say value and label. So we don't need these negates. So now a wire doesn't just go to a gate, a wire goes to a gate or a reference. Yeah? Yeah, I like that better. And then gates go to other wires. I still kind of like this equal gate. I don't like that these are both gates. But still, these two are their own kind of special type. We'll try it. Let's try it and see how it looks. And we'll replace all instances of wire or constant with ref. Yeah. Okay, looking better already. So when you parse an arg, I guess this is like ref.from string. Essentially, it either becomes a constant or a wire given that string. Okay, and then every wire in the circuit now goes to a gate or just a plain reference. Okay, so in this constant case, this will just be, oh, we should import from ref as well. So import ref.star. So instead of going to constant, well, it still goes to constant. But now the left side needs to be wires. I'll just replace C arrow to wire around C arrow. Okay, and this, we can remove this guard and just match, and that two-int option match. So case this is looking familiar actually. It's looking like arg. So we can actually just say, well, let's make this A and B. So we make a wire from B, and we point it to whatever arg we get from A. Cool, that cleans that up. Hmm. Okay, and now this memo goes from a ref to an int. Great, and now when we evaluate a ref, um, well, we still first have to match on the ref, I suppose. Ice cold wedge, welcome. Hmm. Oh, did I never put in my answer? 40149. 40149. Oh, yes, I did already complete it. That's what I thought. I did complete it. So I was just working on day 7 of 2015. Um, and I finished it. I'm just cleaning it up a little bit. And I'm happy with how it's going so far. Michael PC Gamer, how's it going? Um, I think I am happy with how this is turning out. We no longer have these two gates. A circuit goes to, yeah, a gate. There's no equal gate, there's no constant gate. Okay, and now we evaluate the wire A. And this is a wire. There's something wrong with memo 2, or circuit 2. We found a map of wire or gate to wire to gate or ref, and required a wire to gate. We require a wire to gate. Oh, wait, circuit. Yeah, circuit is a wire to gate or ref. So that should be the same thing here. Oh, right. Now you need to match the case where it is a ref. Hmm. Yeah, this is no longer a complete match, is it? Yeah. So case ref. In the case of a ref, we just evaluate that ref. Okay. Mhm. Okay. That's cleaned up a little bit. I'm still not fully satisfied, but at least it's legible. Try Catch TV. Thank you for the raid. What were all of you up to? So right now we're doing Advent of Code. Day 3 problem drops in about 10 minutes, and as warm up, we were going through problems from 2015. And I just finished this day 7 problem. I'll drop the link in chat. It's a fun problem. It's uh it's a circuit, so it's a description for a circuit, and you have to evaluate the circuit to get your answer. Um, and you know what? We have time to go over what my solution was. So the inputs are just these strings. So it says like x and y goes to z, meaning that those there are wires labeled z, and it's like the bitwise and of x and y. Now, this x and y could also be constants rather than labels for wires. So I have this type ref, which is either a constant or a wire. We've got some spammers on YouTube. Cool. Anyway, we've also got our definitions for gates, right? So an AND gate takes two references. So you could add two constants together or two wires together, and so forth for all of these bitwise operators. Excuse the cough. So we have AND or right shift, left shift, and the unary not operator. There are some. There are some. Oh, oh, hold up. Shoot, you do. Okay, you're not a spammer. You sounded like a spam message. So good job at that. You failed my captcha. I see. Let me take charge and give you. Okay, okay. I get the joke. I was about to ban the spam bot. Anyway, um, yeah, here's like argument parsing for any reference. If it can be interpreted as a constant, then it's a constant. Otherwise, we assume that it's a label for a wire. Assembling, parsing the rest of the circuit is pretty straightforward. We just pull those out of strings. And then what we're building here when we build a circuit is a map from the output wire to the gate that defines it. And then we have our val function. So this is also, again, pretty straightforward, right? Constant n goes to n. And everything else, we just recursively evaluate the arguments and then do the appropriate operator. There are all these two ints. They are not necessary. So let me remove that real quick. Okay. And I'm doing something a little tricky here. So there's a lazy val for this whole calculation, for this whole evaluation. And then only calculate it if it hasn't been calculated before. So I have this map I'm using to memorize that. And that's it, my day 7 solution. Nothing tricky. Nothing tricky to write there. All right. Good luck to you too, Michael. um, do we have time? You know, what, let's take a peek at the day 8 problem. This is what we'll have to look forward to after I blaze through day 3 of 2025. Okay, so space on a sleigh is limited this year. Um, oh boy. So I have the notifications on for streamers. Any stream that goes on in the category with advent of code, and I just got 4. So 4 people just went live at the same time for advent of code. Mm. So it's time. About to be 5, yeah. Good luck with your stream, Michael. I might find a BPF in Linux. BPF, you'll have to remind me what that is. Um, escaping special characters. Number of characters in memory string itself. Okay. Santa's list is a file that contains many double-quoted string literals. The only escape sequences are backslash backslash. Okay, disregarding the white space in a file, what is the number of characters of code for string literals minus the number of characters in memory for the values of the strings? Okay. That doesn't seem too hard, but I don't think it's easy enough that we'll do it in the next 2 minutes before this problem drops. So we'll get ready for day 3. Good luck, Alex. XDP firewalling and hooking in general. Um, no, I don't really mess with that too much. I only touch it when I need to. Oh, so it's useful for configuring everything yourself. Okay, Ice Cold Witch, good luck. All right, Shidu, I won't be able to talk about Linux here in a second. But are you doing admin of code? Oh, I need to make up my worksheet file for day 3. Okay, we've got a file just in time. And let's get ready to all right, so that will download, and you got our day 3. Okay, we descend a short. They are all offline. You explain your need to get further underground. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. So the batteries are each labeled with their joltage rating, a value from 1 to 9. You make note of their joltage ratings. Okay, so joltage ratings of all the batteries, they are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Okay. Within each bank, you need to turn on exactly 2 batteries. The joltage that bank produces is equal to the number formed by the digits on the batteries you've turned on. Okay. So if you have a bank with 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, you get 24 jolts. Okay. So this is just a jolt to the batteries. They might not be on. I guess the default is off. So largest possible joltage by turning on only 2 batteries. Okay. So basically, we would need to get the largest digit and make that first. The first appearance of the largest digit, followed by the first appearance of the second largest digit after that. Okay. So val banks is that.toList. And for a bank, largest joltage. So val joltage bank string. And we're going to get some sort of int. So we're going to take a bank.map as digit, and we're going to get the max. So this is digit 1, so we'll call it just D1. Now we need the index of that, so bank dot index of the first occurrence of D1 dot toString. And what do we do to that? We're going to just drop the first that many digits. So we'll just call this index 1, I1, bank.drop I1. And then now we need the largest digit here. So dot map as digit dot max, and this is D2, val D2. And then now our int is just D1 followed by, followed by D2 to int. Okay, so for example, joltage of, let's say 111.9.111.8.111. That's just be 98. Hold on, we still have an issue here. Oh, there's an arrow instead of an equal sign. Not found joltage. Oh, this is a def. Okay. So now we just do the total output joltage. So banks.map. Oh boy, that's not quite right. So let's take this example string. Um, let's do dot index of 9. And then we'll take that again. Drop 3. So we need to drop +1. So the index +1. Okay. So now that should work. And we'll take banks.map joltage.sum. Empty.max. There's an empty.max somewhere. Oh, okay. We need to handle a special case where the index is the last. Okay, so in that case, D1 is actually D2. Let's do it. It's going to be a little bit hacky, but we can clean it up later. So if I1 equals bank dot length minus 1, then we take the next max. So bank dot init map as digit dot max. So this is the next max. We'll call that D2. And then we make it in reverse order. So we have D2, D1. I hope we don't run into an issue with zeros. I don't think we will. D2, D1 dot to int. All right, else we do it the normal way. Okay, now that should work. 17,100. 17100. Okay, part 2. The escalator doesn't move. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. Exactly 12. Okay, so we need to clean up our approach and make it make it scale to 12. Okay. Well, what we could do, so for digit 1, um, instead of just getting like the max, since there will be 11 more digits, we get the max of the first n minus 11, right? And then we can make this recursive, and Joltage can have an argument. So that cleans that up. We're just gonna comment out the old version. And we have uh, batteries required. So and then we can stop doing this like string concatenation and just do like times 10. And then we go recursively. So val digit equals bank dot take. Um, what would it be? The full length of the bank. So bank dot length minus batteries plus 1. Right? So we're not going to worry about the last 11 in the case of 12 batteries. And dot max. Now we don't have to worry about the index. Actually, we do still, because we're gonna shrink the bank every time we pass it along. We're gonna shrink it. Okay, so val index equals bank dot index of d1 dot to string. Okay. Mhm. I should be representing bank not as a string anymore, but as like a sequence of digits. But let's not worry about that for now. So now we do joltage recursively. We multiply like this one by 10. I think we should have like the number so far. So we'll have like an accumulator. We'll make this tail recursive. Um, and then like add R value to that accumulator. So joltage bank dot drop index plus 1. Uh, batteries minus 1. And the accumulator times 10 plus the digit. Okay, so now if batteries is 0, if batteries equals 0, then we just return that accumulator. Otherwise, we go into this tail recursion. It's even shorter code than my original, so I should have just written that in the first place. Okay, so end one is going to be the joltage given 2 batteries, and then an accumulator starts at 0. Oh, wait, yeah, joltage of the bank given 2 batteries and starting at 0. Oh, this was bank.map. Oh, wait, no. Bank.take. And D1 is actually digit. And that should compile. I think that is run. Great. We still get the answer. Nope. That is a different answer than we got earlier. Um, okay, so let's try joltage out on some test strings. Mhm. So 2. Let's try 111982211. That should just be 98. And then let's try 897. Wait, 626. How are we getting 626 in there? Okay, so digit.toString. Well, what is digit? Is a character. Wait, you have to map them as digits first. So dot map dot as digit dot max. Okay. Give that a second to update. 98 once. Okay, good. So we fixed that. We're still getting the same answer for part 1. Now we just change that 2 to a 12, and we've got part 2. That felt smooth. That was a smooth transition. Oh, and 2. Okay, I feel satisfied. Uh, Update. Oh, longs. Um, cool. Let's make that a long. So the accumulator starts. Let's just default that to 0L. Right, they're 12-digit numbers. They're going to be pretty big. Okay. Has it updated yet? It doesn't appear to have. Okay, there it is. 17041819. 2256861. Alrighty. That was a fun one. Okay. So who all has anyone here finished it so far? I'd be curious to hear about other people's approaches as usual. Let's see who's finished on my leaderboard. We have. Oh, it hasn't updated yet. I don't know why the leaderboards are so slow to update this year. Oh, Brett, hey, it's been a while. You use memoization? Oh, okay. I suppose memoization could help here. Well, I mean, it runs in under mine runs in under a second. Sparkly Dark Matter, you just watch. I think maybe it did it one past year, right? If I weren't doing it, I'd definitely be wanting to watch it. Maybe one December if I'm in a hospital bed. I found a nice way to do it with tail recursion here. And my part two code actually ended up being shorter than my part one. It's just more generalized, a lot cleaner. I had to handle special cases the way I had approached it at first. And now those just don't exist. What exactly would he be memoizing? Because you don't see the same battery bank twice, right? I mean, it should be unlikely. Are in this leaderboard, Brett? Each bank. Oh, for the, I guess because you run it 12 times in each bank. Sparkly, you did AOC for a few years until pathfinding. But now you've forgotten how to code. Fair enough, it does get rusty. Yeah, the pathfinding days are killer. Um, I didn't podium anything, right? I'm just trying to reload this page. You suppose there was 1,000 digits in each bank? Oh, right, yeah, 1,000 digits in each bank, sure. I never even looked at the input data. I just kind of assumed. I know. I just assumed they were shortish, but I never even thought about that. Okay, there's like 100. Hmm. All right, well, the leaderboards are just slow to update this year. I got part one in 7 minutes. I think 15 minutes for part two. Fair enough. Okay, well, now there's back to 2015 problems, I suppose. I could get through day 8. Maybe day 9 if it's interesting. To be honest, day 8 seems a little bit tedious. Maybe it's interesting. So every escape character counts as just one character, right? It's like one character in memory. I don't know what the escape patterns are though. Um, right. So the quotation marks are characters. This is 5 characters. This is 10 characters of code, but string itself contains 6 A characters and a single quotation. Okay, so it's not just that we have to count the amount of space. I think we have to count which characters are actually characters. Um, so 10 characters of code. 10 characters of code is straightforward. It's just the length of the string. Okay, so we just remove the first and last quotation, and we remove every subtract 1 for every slash in there. This is 6 characters of code, but the string itself contains just 1. Oh, wait, because x20, this whole thing is 1 character. So this whole thing is 1 character. Um, oh, so this is according to like, this isn't their own escape sequences. These are just our regular escape sequences. Oh yeah, thanks. Thank you, thank you. Um, Honestly, the motivation for my solution wasn't any like greedy or algorithmic thinking, but just I don't know, wanting it to be recursive. All right, so does isn't this like programming language specific? Might different uh I suppose most I think we can just assume all the languages have the same escape sequences. If I'm understanding this problem correctly, what is the number of characters of code for string literals minus the number of characters in memory for the values of strings? Um, I suppose we could specifically look at slash x20. Okay, let's look up slashes and backslashes in here. Okay, so backslash x fb. This is not anything that I know. I that's not even a number. Yeah, that's that's invalid for me. Okay, so how's the x interpreted according to this? Um, Many double quotes, string literals on each line. The only escape sequences used are slash slash, which represents a slash, slash quote, which represents a lone. Okay, this is what I'm looking for, which represents a lone double quote character, and slash x plus two hexadecimal characters, which represents a single character without ASCII code. Okay, okay. And it won't be sufficient just to. We'll need to parse the characters one by one, I suppose. Look at the start of the string. Yeah, we'll look at the start of the string and just pick them off one by one. Um, right, like it won't do just to search for like slash quote or like well, we could search for all the slashes. They all basically translate to subtract one, except this one, right? The first one means subtract one, the second one means nothing. Okay, so we'll just parse them one by one. We'll not try to do anything clever. Okay, day 8. So let's map on the input, or let's make our function first. Um, Memory count, I guess we'll just call it count. So given some string, and now we pick off the first bit of the string. Um, well, it's always going to start with the quotes, and we won't count those. We can handle that in a separate step. And then here we're just looking for slashes. Okay, so if s dot starts with, can we match? Let's do s match case. Um, okay, let's say it starts with a slash um, and a quote. can we do a raw string? Let's do a raw string here. Okay, so if it's slash quote, and then we have the remainder, then we do +1 and we go recursively. Equals goes to 1 plus count rem. Okay, that pattern can work for us. So now if you have slash slash and then remainder, 1 plus count remainder. And now if you have slash x, um, the first two characters of remainder will not be necessary. So 1 plus rem dot drop 2. All right, and the only other case, oh, well, the case is anything else. Well, let's handle the empty string case. Let's put that first. So an empty string will just go to 0. And then any other string goes to 1 plus count rem dot drop 1. Okay. And now we do input dot map. So we take our string and we just take the inside. So we're going to remove the quotation marks. Right. Or you know what? This thing will just count the quotation marks normally, and we can subtract 2. So we can do like count that minus 2, and then dot sum. Ian Beckett. My day 2 solution was nice. It renewed your interest in practical functional programming. Oh, hey, thank you. Um, by the way, so I wrote a blog post for day 2. It's not published yet, but it's for the Scala Center. And every day, someone different writes a write-up of the solution. So I'm doing days 2 and 9 this year. I'll post it in chat, or the pull request anyway. When it's published, I'll show it on stream. The implementation here is a little bit different. So like my invalid 1, I'm happy with how clean this is. So we take ID and turn it to string, and then left and right is just string that's split at length divided by 2. And this returns a tuple, right? So we just assign it to left and right. If the string is odd length, we don't really care, and we just check that left equals right. And for part 2, I did some math. I felt like the math was clean. I won't dwell on that for too long. It's explained in this post. And then I wrote, a couple of add-ons. So if you wanted to use regular expressions, it'll be a lot shorter. And if you want to optimize it, here's an approach you could take, but I don't elaborate too much on either of those. And this is where that will post eventually. You don't need to consider 1, 2, 1, 2, 1, 2, 1, 2. I mean, for the triple case, that will show up because what I do is I take a string like 1, 2. Well, first it's length 6, right? So 2 is a proper divisor of 6. So I find 2. I take the first 2, and then I just take the first 2 characters and I repeat it until it's a full length of the string, and then I compare that with the string. And that blog post will drop here eventually, and I'll show that on stream when it's published. But yeah, thank you. I'm glad you liked it. For those wondering, here it is. It's pretty short, so I'm happy about that. Okay, so back to day 8. Oh, there's no rem here. We just do s.drop1. So what's the goal here? What's the number of characters of code for string literals minus the number of characters in memory for the values of the string in total for the entire file? Okay, so it's going to be get the string s.length minus um minus the count for s minus 2 to remove those two quotation marks. I hope that's right. It's not like a legible way to handle the quotation marks. It has a little bit of magic hidden there, but it should at least be correct. Um, Invalid escape. Oh, right. I gotta escape my slashes. Wait, I still have to escape my slashes even in a triple quoted string. Is that so? Okay, well, I'm gonna go back to a single string and we'll just manually escape everything. Fence posts all day. So slash, and then the X slash. Geez. Escape the slash and escape the quote. Okay, that's fun to read. Okay, it ran instantly. For some reason, my worksheets are not updating instantly. Oh, we need like the sum of this, the entire file. Okay, dot sum to get our answer. It's a red flag that there are negative numbers in here. Okay, let's do some testing. So let's count for a string like A, B, C. This will come out as 5 characters, but it should actually be just 3 characters. That's why we have the -2 though. Um, I'll just do it on the insides. I want to test this x27. This should come out as just 1 character. Of course, they're gonna be off by 2. Oh, okay, we have to escape the X. Or escape the slash. Okay. 5 and 3. I mean, those look correct. I hope s.length is working properly. S.length should always be longer than count. So this should never be negative. What we could do is filter for inputs that turn out negative. So, okay, we get 142. Might as well try that. Yeah, that's not right. So input.filter, we want strings such that count s -2. Oh, hold on. Wait. We're subtracting -2. There should be parens here. So let's just count how many cases there are, see if there are any. So s such that count s minus 2 is less than 0. I think this should give us the correct answer now. Because that would put us off by a factor of 4 to subtract 2 instead of adding 4 instead of adding 2, right? Okay, 1342. That sounds better. Okay, we'll do part 2 in a second, but I need to use the bathroom, so I'll be right back. All right, we are back. Part 2. I haven't had a chance to read this yet. So now let's go the other way. In addition to finding the number of characters of code, you should now encode each code representation as a new string and find a number of characters of the new encoded representation, including the surrounding double quotes. Okay, this is hurting my head a little bit to read. Okay, so this encodes to, wait, what? Okay, we encode it as a new string. This encodes to, right, because you escape both of those, and then we need the characters needed to represent that, which will include the surrounding quotes, the +2. Okay. You know what? I could handle the quotations in here. Let's get rid of this -2 altogether. Just clean that up a little bit before we move on. So, case, if it starts with a quotation that has not escaped, um, and then, we get the remainder. Then, in that case, we do just a recursive count. Right? Any other strings, any other quotation marks will be quoted or escaped. So that should still give 1342. Great. Okay, so now we need an encode function. And then we do a count of the encode or just a normal. Let's make sure we understand what it's asking for. So val and2 is going to look like the total number of characters to represent the newly encoded strings minus the total number of characters of code in each original string literal. Wait, the total encoded length is 6 plus 9 plus 16 plus 11. Oh, wait, yeah. So this is 6 minus the characters in the original code representation. Right, which is going to be 2 plus 5 plus 10 plus 6. 23. Okay. So basically, it's going to be like input.map s to encode s.length minus s.length. That's what it's asking, right? That's and then we just need to define encode s string into another string. Okay, we can do that. So now we do this character by character. We could still do it recursively the way we were doing it before. This could also just be a flat map. Take each character and potentially turn it into more characters. So s.flatMap, I'll put that up here. So we have a character, and well, we're going to do a pattern match here. So case, if it is a quote, if it's a quote, then we're just return a string. Yeah, if it is a single quotation, we need a slash and then a quotation. Okay. And then if it is a slash, then we return 2 slashes. All right. And if we have x followed by the 2 characters, basically just x. We don't need to think about the rest. Oh, hold up. What happens here? We don't even need to consider the fact that it's an x. The fact that it's a slash is already handled here, right? So we just handle slashes and quotes. That's it. Case C goes to C. And that makes string right at the end. Okay, let's test that. So let's encode, for example, x27. Let's just encode all examples. So there's a quote, code ABC. So, okay, quote ABC, quote. And then there's encode, quote AAA, slash, quote AAA, quote. Oh, and this here is missing its quotes. All right. Oh, we just make this a single character, I suppose. In which case we don't need to do any escaping. Oh wait, no, there's a single quote character and then a single slash character. Um, and yeah, overlap mapping it into new strings, that's fine. What's going on here? Wait, do we need a double slash? I see. We still need to escape the slash there. Okay, dot two string. Okay, let's see if that works. So this goes. Oh, we need to have the +2 quotes around the end too. Um, right, and then this one here. That looks correct. Slash quote slash slash x27 slash quote, and we just need the quotes around the ends. So make string actually takes three arguments. It can take like the thing that you put in between everything, um, which in this case is nothing, and the things that you put at the end. And that should make those correct. Uh-huh. 2074. Great. Okay. So I think I'm definitely in a harder part of 2015 than I am in 2025. We can remove these tests. So we solved three problems tonight. Day 7 of 2015, day 3 of 2025, and day 8 of 2015. I'm not sure. Let's see, what did I give myself, like an hour before? I'm not staying up until 2 a.m. tonight, but later this week. I just have to get up early tomorrow. I think it should be possible to finish 2015 and 2025 at the same time. I'm hoping that I can finish 2015 like the night before the final prom of this year drops. But we'll see. We're kind of trying to fit like 3 times the admin code into half the time. So I need to get ahead as far as I can before 2025 gets hard. Um, but yeah, that's enough of that. That's pretty satisfying. Let's look for someone to raid. So, who's streaming with the admin of code tag? Bad Cop's on. Alka's on. Although I'm not sure if Alka is still working on admin code. Here, let me remove the tag and see who else shows up. Bye, Ice Cold Witch. Thanks for being here. Okay, let's search Advent. Oh, so Bad Cop is doing this with Dave Eddy. Cool. Alka. I'm not sure Alka is doing admin code right now. I imagine Alka's done well by now. But these two are doing it in Bash, so they could still be working on it. Um, hey, there's me. Voilin. We could read Voilin again. Oh, Temporalis. Um, yeah, I remember temporalis. We've seen him around. Let's go cheer him on. All right. Well, thanks everyone for stopping by. Hope you all have a good night. And yeah, let's definitely cheer on temporalis. All right. And to you on YouTube, not rating, thanks for stopping by there and have a good night.